Assalamualaikum. So for today class, we move to the next subtopic in chapter 4, which is superposition. The superposition theorem states that the voltage across or current through an element in a circuit is the algebraic sum of the voltage across or current through that element due to each independent source acting alone. Actually, superposition is another technique that you can use instead of using mesh or nodal analysis. So you also can use a superposition theorem in order to find the voltage or the current value for the circuit. So superposition can be applied for the circuit that have more than one sources. Okay, so that's why we call it as a superposition by assuming at one times only one element or one source is active. So that's why in the superposition theorem, uh, uh, we are looking for the current or voltage value by considering only one independent source active at one time. Okay, so but at the end we will do we will find the total voltage or the total current by do a summation of the voltage and the current value. This theorem helps us to analyze a linear circuit with more than one independent source by calculating the contribution of each independent source separately. That means we need to consider one independent source at a time while other independent sources are turned off. When I say turn off, that means if your circuit consists of voltage source, in order to turn off your voltage source, so you need to short circuit the voltage source, right? So if your circuit have a current source, in order to turn off the current source, you need to open circuit the current source. That means we want the value of voltage source become 0. So that's why we short circuit, and then we want the current source become 0 ampere. So that's why we do open circuit for the current source. For dependent source, you need to left the intact because they are controlled by the circuit variable. So that means this superposition theorem only can be applied to the independent sources. So the dependent sources that you have in the circuit, you must remain that dependent sources in the circuit, because we know that dependent sources usually they are controlled by circuit variable. So this is steps, 3 steps that you need to consider in order to apply superposition theorem. So the first one, you need to turn off all independent sources except one source, right? And then you need to find the output voltage or current due to the active source using any available technique covered in the previous chapter. So when we said available technique, so that means you can use mesh analysis, you can use nodal analysis, or you can use source transformation and so on, right? So next, what you need to do is you repeat step 1 for each of the other independent sources. So let's say if your circuit consists of more 3 sources, so that means you need to repeat these steps 3 times, right? So at the end, after considering at one time only one sources is active, and then we find the value of V and I. So the last step is actually to determine the total contribution by adding algebraically all the contribution due to the independent sources, right? So maybe we need to see the example in order to really understand what the fact here, right? So We go to the example. So you need to use a superposition theorem to find V in the circuit of figure 4.4. So this is the V that you need to find. Alright, so if you see in this circuit, you have two sources over here. The first one is 6 volt voltage source. The second one is 3 ampere current source. So therefore, we know that we can apply superposition theorem. Both are independent sources. So we know that we can apply superposition theorem for this circuit. Alright, so remember, in superposition theorem, we consider that at one time only one sources is active. So this is the solution. Since there are two sources, so let V equal to V1 plus V2, right? So V is actually the voltage that we are looking for, the value of the voltage that we are looking for. But we know in a superposition, we need to consider one active source at a time. So therefore, V1 is actually the contribution due to the 6 volt voltage source. Okay. And V2 is the contribution due to the 3 ampere current source. So when we say that V1 is due to the contribution of 6 voltage source, so that's mean at this time 3 current source must be turned off. Right? So or 0 ampere. So when we say that V2 is the contribution due to the 3 ampere current source, so that's mean at these times your voltage source must be equal to 0 volt or must be turned off, right? Okay, so let's start. We are looking for the V1 value first, right? So V1 value is due to the 6 volt voltage source. So therefore, you need to turn off the 3 ampere current source. So in order to turn off the 3 ampere current source, you need to open circuit the 3 ampere current source. So therefore, if you see in this circuit, there's no more 3 ampere current source in the circuit. Right? So this is how the circuit look like when we set the value of the current source become 0 ampere. So now this circuit is actually a series circuit. So this is the value of V1 that we are looking for, right? So therefore, by applying KVL, right, so around the loop, so we can get the value of I1. So by knowing the value of I1, you can find the value of V1 using Ohm's law, right? So therefore, okay, by applying KVL around the loop, so this is what you got. 12 I1 minus 6 is equal to 0. And then I1 is 0.5 ampere, which is 6 divided by 12. So you got 0.5 ampere for the value of I1. So when we know the value of I1, so we know we can find the value of V1 over here. V1 is actually 4 times I1, right? So 0.5 times 2 times 4, is equal to 2 volt. So therefore, the value of V1 is actually equal to 2 volt over here. So you also can use voltage divider rule. Okay, if you don't want to use the KVL over here, you also can use this method, another method over here. This is the first one, this is the second one. So you can use a voltage divider rule. So therefore, this is how we apply voltage divider rule, which is 4 divided by total resistance over here times with your voltage source. So therefore, V1 also equal to 2 volt. Right? Alright, so next step, we need to find the value of V2. So in order to find the value of V2, if V2 is actually due to the contribution of 3 ampere current source, so therefore at this time 6 volt must be turned off. So in order to turn off the 6 volt, right, so you need to short circuit the 6 volt voltage source. So therefore, if you see here, there's no more 6 volt, right? So now we are looking for the value of V2, right? So in order to find the value of V2, you need to know the value of I3, right? So I3 can be found using current divider rules. So this is current divider rule, which is I3 equal to 8 divided by 8 plus 4 times 3 equal to 2 ampere. So therefore, the value of V2 is actually I3 times 4, right? So 2 times 4 is equal to 8 volt. Alright, so now we know that this value V2 equal to 8 volt. So therefore, V is actually equal to V1 plus V2, which is 2 plus 8 equal to 10 volt. Alright, so maybe you can try, check, okay, so whether this answer is correct or not by using maybe you can use a nodal analysis and so on in order to check whether you got the same answer. If we use a superposition theorem, should be you got the same answer, guys. Alright, so this is superposition theorems. I think it's not that complex. So as long you know that superposition theorem, you need to consider at one time only one independent source is active. Another independent source need to be turned off, right? So if in your circuit you have three independent sources, so that's mean you need to consider all these three independent sources, and then at the end you need to do a summation of for all the value that we got, right? So it's quite complex. Superposition will be quite complex for the larger circuit. Maybe for the, let's say, if your circuit have four independent sources in the circuit, that means you need to repeat 4 times, right? But if you look back at the superposition theorem, actually by turn off another source in the circuit, you make the circuit more simple. So therefore, the value that we are looking for is not involved that massive calculation. So that's the advantage, but the disadvantage actually you need to do for a larger circuit, you need to repeat the step depends on the amount of sources in your circuit. Alright, so for today class, I want you to do this exercise. Okay, so as your proof of attendance for today class. Okay, I think I'll stop here. So thank you guys.